Today we're going to talk about prime factorization. Prime factorization is where you take a number and you break it down into all of its prime numbers. I like to think of the prime number as prime numbers of a number being like its fingerprint or its DNA. You're breaking it down into the tiniest parts that make that number up. Every number has a unique prime factorization. Just like everyone has unique DNA, every number has its own special prime factorization pattern. No number has the same prime factorization. An important thing to keep in mind are these 5 common primes, because these are the ones that you're going to see most likely, and this at least gives you a starting point if you get stuck and you're not sure how to start breaking a number down. Another one that I always like to include, however, is also 13, because 13 is also pretty common when you're a 6th and 7th grader. But for the most part, 2, 3, 5, 7, and 11 are the ones that you're going to see most frequently. Remember that a prime number is a number that only has 2 factors, 1 and itself. And you'll see that 1 is not included as a prime number here because 1 is very special. It only has 1 factor, which is 1. So 1 is not considered a prime number. Let's start here. We've got the number 24, and we are going to break this down into its smallest pieces. And the way this works is we're going to use what's called a prime factorization tree or a factor tree. And we're going to start with the number 24, and we're going to think about what 24 looks like, what multiplication problems we can use, what factors we can use to arrive at 24. And when I think of 24, I think of 2 and 12. Now, 2 times 12 definitely gives me 24. And I'm going to look at these and I'm going to say, okay, well, 2 is prime, so I'm going to circle it because then I know that branch of my tree has stopped. 12, however, is composite. It has more than 2 factors, so that means I have to continue on that side of my tree. My goal is to get every branch of my tree to where they are all prime numbers. So when I think about 12, well, 2 times 6 would give me 12. So I branch this down into 2 and 6. 2 is prime, so I'm going to circle it. 6, however, is composite, so I have to keep going. To get 6, I would multiply 2 and 3. 2 and 3 are both prime. So now I know that I have my number broken down into all those primes. I circle them just to make it stick out a little bit. So now when I look at this, let's see. I'm going to write this in factor form. We talked about factor form yesterday. It's where I'm going to write this number written in all of its primes and in all of its factors, the things that we would multiply together. Now, it's important that you remember to put these in order from least to greatest. So I'm going to write 2 times 2 times 2 times 3. And now if we actually multiplied that out, we would get 24. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So you see how we're using what we did yesterday. Now that I have this in factor form, I'm going to write it in exponential form. So I'm going to start with a 2 because that's my first factor. And I have 1, 2, 3 2's. So my exponent is 3, so it's 2 to the 3rd power times 3. I don't need to put an exponent on that 3 because there's an understood 1 that is already there. Okay? So 2 to the 3rd power times 3 would be the prime factorization for 24. And then, of course, the standard form of that is 24. Now, I want to show you how each number, it's not going to matter where you begin with your tree. You can start with any multiplication fact that you know gives you that number, and you're still going to get the same prime factorization. And I'm only going to show you this on one problem. So let's say that instead of starting with 2 and 12, you decided to start with 6 and 4, because 6 times 4 is 24. Well, neither 6 nor 4 is prime, so I need to branch from each of these. So to get 6, I would multiply 2 and 3, and both of those are prime. And to get 4, I would branch 2 and 2, and both of those are prime. So now if I write this one in factor form, I want to make sure that I put them in order. I have 3 2's. We're always least to greatest, so it's 2 times 2 times 2. So I took care of the 3 2's, so now I'm going to take care of that 1 3 times 3. And if you notice, these prime factorizations are exactly the same. So then I have 2 to the third power again, because there's 1, 2, 3 2's, times 3. And my standard form is 24. Let's look at another number, because you guys are not wee ones anymore, so you might have some that are larger. So we've got 117 here. And some of you may already be saying, oh, that's prime. No, it's not. It actually is not. One thing that you can do is when you are looking at a number, we know that this cannot be divided by 2 because it's odd. It ends in a 7, so it's odd. So the next thing that I always go to is I add up the digits. So the 7 and the 2 1s, I add them together and I get 9. So that tells me if I add them together, it can be and get 9, that it can be divided by 9. But it also tells me that 9 is a multiple of 3, so that means that it can also be divided by 3. So I know I've got 2 options here with what I want to work with. And I'm going to go ahead and I'm going to use the 9. So I'm going to start here, a branch of 9, and I've got to figure out what times 9 is going to give me 117. Well, let's see, 9 would go into 11 one time. It's going to be 13. I know 13 is prime. 9 is not, however. It's a common mistake. Kids think that 9 is prime. So now I'm going to take that 9 and I'm going to branch off. It would be 3 times 3 to get 9. And so now I have all primes. So this prime factorization is done. So let me write it in factor form. It's going to be in order from least to greatest. So 3 times 3 times 13. I have 2 3's, so in exponential form it would be 3 to the second power times 13. And then in standard form, it's the 117. Pretty simple. Prime factorization is something that we practice to help you get used to a skill called factoring, which is something that you will do as you solve more complex math problems when you get into algebra. So that's why we practice it in the younger grades, to get you there and get you ready. Have fun today, guys.